Hello everyone, this is Adhish. I'm a grade 10 student from Mumbai. So today's problem is planning vacations. The difficulty level of this problem is cakewalk and you only need to know loops and some basic greedy ideas. However, since this is just the second problem of today's contest, you only need to know loops and some basic understanding of a greedy idea or greedy algorithm. So in this problem, we are basically given n hours as a string, binary string of length n. So for each I going from 0 to n minus 1, if we take 0 based indexing, SI is 1 if chef has to work during the ith hour, and SI is 0 if chef is free during the ith hour. Now chef would like to take some naps, so he needs k consecutive free hours to take a nap, and he needs to find the maximum number of naps he can take in the next n hours. So basically for each test case we need to answer this, and since the number of test cases and the sum of n can be up to 2 into 10 power of 5, we need to find an O of n solution or n log n. So let's think along those lines in which we can only process the string once in one go. So for example, let's say that the value of n is 4 and the value of k is 1 and the binary string is 101 01. So it's a string of length 4 which represents that chef worked at, he was working on the 0th hour, he was resting during the first hour, working during the second hour and resting during the third hour. So you can take the first nap and the second nap in this way, and that's why the answer would be 2 because he takes 2 naps. In the second example, he can take a nap for 2 consecutive zeros. So there is only one occurrence of 2 consecutive zeros, that's why the answer would be 1. So in the third example, you'll notice that there are 7 zeros over here, and in these 7 consecutive zeros, he can take a nap twice because 2 naps would take away 6 of his zeros. 1 zero would be left, which would not be enough for a nap because nap requires 3 zeros. So in general, we are trying to take the consecutive zeros and we are trying to fit in for each segment of consecutive zeros what is the maximum number of naps he can take. So let's consider that simpler problem. So let's say that the string of length n just had all zeros for a simple example, and this is a simplification of the problem because the final solution is just going to be the sum for all these n's. So for each, so let's say we split the binary string like this. So let's say that the binary string was like this, for example, where there were zeros, then there was a 1, then there were again some zeros, then there were a few ones, and there were zeros. And if we are able to find out for each consecutive segment of zeros what is the maximum number of naps he can fit in those consecutive zeros, then we just need to add up the value for each segment. And that's why essentially what we need to do is we need to take an example where we have a string of length n and find out what is the maximum number of naps chef can take if he needs k consecutive zeros. So to answer that question, let's take an example where we have 3 consecutive zeros and k is 2 and k is 2. This means that this means that we'll be only able to print 3 by 2, 3 integer division 2, which is 1 nap, because we'll only be able to take one one pair of zeros. And if you consider another example where we have 5 for example and k is 3 for example, or if we had 7 and k is 3, then in this case we would take 7 integer division 3, which would give us 2, because we could only take 2 pairs of 3s, and I mean 2 segments of 3s. And in general, the answer for a contiguous segment of n zeros is just n by k integer division, and we could just take integer division Python, or we could just divide by k where n and k are integers. So in this way we know that for each contiguous segment, so for example let's say that this segment has length 4, so it's going to be 4 by k integer division, and this number of naps would be 3 by k, and the number of naps over here would be 5 by k if we had 5 consecutive zeros. So in this case, in this way, we would just keep track of how many consecutive zeros are there, and we would just add them. We would add the number of consecutive zeros divided by k, where we take integer division. So this is the general algorithm. Now, in order to implement the idea for finding the number of consecutive zeros, let's start by initializing the variable current to be 0, where current represents the number of consecutive zeros so far. We will loop through each index of the string because the indices go from 0 to n minus 1. So we'll go for all I in the range 0 to n, and we would basically keep track of how many consecutive zeros are there so far in the variable current, and the final answer would be represented in the variable answer. So answer represents the sum of the values of n by k, where n represents the sequence of consecutive zeros, and that's stored in the variable current. So for all I going from 0 to n minus 1, if the current character is a 0, we will just increase current by 1 because we know that it's going to be a 0, so the number of consecutive zeros will increase by 1. Otherwise, we know that there's a break or 1 has appeared, and that's why we'll increase the answer by current divided by k, where we are doing integer division, and we will set the current value to be 0. So in this way, we ensure that we are always storing how many consecutive zeros are there in the variable current, and dividing that by k will give us the accurate value of the number of naps that chef can take. And in this way, in the end, we will just increase the answer further by current divided by k, because in case we have reached the end of the string and we have some zeros left in the end of the string, we need to consider that also in the answer, and that's why the answer would increase by current by k. In the end, we would just print the answer because that represents the number of naps for each of these consecutive zeros, and that's what exactly the question is asking us. So the code for this would be, for each test case, we will take in the value of n and k. We'll take in the string s. Cur represents the current value, the current number of consecutive zeros, and answer represents the final answer. So for each I going from 0 to n minus 1, if s of I is a 0, we'll increase current by 1. Otherwise, we'll increase answer by current divided by k, and we'll set current to be 0. And in the end, we just increase the answer by current by k, where we take integer division and we'll print the answer. And I've done the exact same thing for Python, except we take in each line separately. That's why we need to use this method of taking in the input, and the main part of the logic, which is the loop, remains the same. And essentially, we are storing how many consecutive zeros are there in current, and we are setting it to be 0 in case we encounter a 1, and in case we encounter a 0, we increase it by 1, and in the end, in case there are some leftover zeros, we would increase the answer by the number of leftover zeros, integer division by k, and in the end, we print this answer. So you can verify that this code does get accepted. So I hope you like this problem and my solution.